Welcome. This is Beyond Greenfield, reverse engineering patterns for AI coding agents working on Brownfield systems. Brownfield is the code you inherited. Legacy, multi-repo, undocumented, and already in production. Let's get started. Greenfield means new code, built from scratch, and it is easy for an agent. The spec lives in your head and the code is born from it. Brownfield is the inverse, an existing system you inherited, already in production. The code is the only reliable spec, it is undocumented and contradictory, and no one person holds the whole system in their head. So the failure mode is not broken syntax. It is code that is locally correct and breaks a consumer 3 hops away that the agent never knew existed. The hops are real: a shared client library, a queue topic, then a nightly job in a repo nobody on your team owns. Bigger context windows do not fix this. The context window is the fixed amount of text a model can hold and attend to at once, and the problem is not capacity. It is knowing which code matters, why, and how it connects to your change. The answer is not one rigid pipeline. It is 4 reverse engineering patterns. Each runs independently, each produces a durable artifact, and each can use another's output when it exists without requiring it. Pattern 1: reverse engineer a repo. Point an agent at a single repository, and it produces one durable document that explains how that repo is built. Pattern 2: map dependencies across repos. Read those per repo documents and assemble the dependency map between them without reanalyzing code. Pattern 3: intent-driven change analysis. Take a change you actually want to make and work out exactly which repos and files it touches. Pattern 4: keep it fresh. Hang a hook off the merges you already have so none of the documents go stale. Before the patterns, the primitives you build them out of. 4 building blocks and they stack as layers. A skill is not code the agent runs, it is instructions the agent reads. A named version-controlled module loaded into the model's context when you invoke it, carrying a method plus a fixed output format so every run produces the same shape of document. An agent is a language model running in a loop. It takes a goal, picks a tool, reads the result, and repeats until done. You configure its persona, the tools it may call, and the permissions those calls run under. A subagent is a child agent with its own fresh context window. The parent hands it one bounded task, it works in isolation, and it returns only a summary. That is how a system analyzes far more than any single window can hold. A connector is a server that exposes an external system as tools the agent can call while it runs. Usually an MCP server. MCP, the Model Context Protocol, is the open standard that lets any agent talk to any tool server. Now the principle underneath all 4 patterns. Reverse engineering from raw code alone stays shallow because the code shows what the system does, while the why lives elsewhere in your organization. So ground the agent 2 ways. Curated, stable knowledge goes into skills, design patterns, architectural principles, and naming conventions, plus domain language, business rules, and compliance constraints. Living high-volume knowledge comes through connectors, Jira for the history behind a change, Git commit history for recorded rationale, and wikis, design docs, and ADRs, architecture decision records for the rest. Version: what changes slowly, connect to what changes fast. That grounding is what recovers the knowledge departed engineers took with them. Pattern 1. Point an agent at a repository and it reads what a senior engineer reads in their first week. Entry points and manifests establish the stack, framework, and version era. The public surface is the APIs, events, and interfaces that others depend on. The data model, schema, and migrations say what the service is actually for. It traces a few core flows end to end because following one request completely teaches more than skimming everything. Then it maps external wiring, what the service calls over HTTP, queues, and third-party integrations, because that is where the real coupling lives. The document is committed into the repo and stamped with the commit it describes, so it lives beside the code and gets reviewed in the same pull request. Risks and unresolved unknowns get flagged rather than guessed. This is the first thing you hand a coding agent working in this repo. It tells the agent the conventions to follow, where the public surface is, which flows a change will ripple through, and what to cover in tests. There are two ways to produce it, and the choice is real. One skill hands a single agent a comprehensive instruction and lets it write the whole document in one pass. Write for a small or medium repo. Past a certain size, the repo stops fitting coherently in one context. The pass goes shallow and misses what sits at the edges. Auth middleware, wrapping a function, a data transfer object serialized at another layer, tests in a sibling repo, migration scripts. So fan out into parallel specialized subagents, each scoped to one facet: backend and services, data model and migrations, API and public surface, frontend, tests and CI, and decisions and why from history and tickets. Each returns a compact section, and a synthesis pass stitches them into one document, which recovers the cross-cutting visibility you lose between workers. Start with one prompt. Switch to the swarm when the repo stops fitting or the output thins. Pattern 2. To understand how several repos relate, build the picture from the reverse engineering you already did, not by reanalyzing code. Match what one repo consumes against what another exposes. Repo A consumes a user events topic, repo B publishes it, and that is an edge, established without opening either codebase. A clean match across two documents is high confidence. An edge only one side mentions is low confidence, and that one earns a targeted deep dive into the source to promote it to certain. The output is a general dependency document, held in a central architecture repo, but it is intent-free. It tells you which repos are connected. It cannot tell you which connections matter for a change. For the coding, this is what stops an agent finishing a change in one repo while silently breaking another. When it changes a contract, it knows which downstream repos and integration points need attention, which is what pattern 3 is for. It starts when you have a change in mind, because impact is a function of intent and cannot be pre-computed. It runs at three altitudes. It starts from the general dependency document to see which repos are in play. It pulls those repos documents to understand what each one does and where the relevant surface lives. Then, only where the change actually lands, it drops into source to find exactly where the edits go. The output is a change scope dependency document, alive only for this piece of work. It carries the intent, the specific repos and files the change touches and the contract changes. Then the ordered sequence, the compatibility window, the integration points to test, and the rollback path. Because it belongs to the work rather than the architecture, attach it to the Jira story so it travels with the change. A reviewer agent checks it for hidden coupling and one-way doors, and a human approves before any code moves. This is the point of producing it. The per repo documents tell the coding agent how each repo is built. This one tells it exactly which files to touch, in what order, and which integrations to exercise. Pattern 4. Reverse engineered documents rot on the first merge, so keep them fresh with a hook on the code change events you already have. A GitHub action, a workflow that runs automatically on a repository event, fires on a merge, a release, or a CI run. It gathers the diff, the linked ticket, and the pull request description. It loads the last document as its baseline, leaves the unchanged parts alone, and updates only the sections the change touched. Faster than regenerating and richer because the diff shows what changed while the ticket shows why. The agent opens a documentation pull request and a human merges it. Nothing auto-merges. And when a per repo document updates, the dependency document resynthesizes off the new version. This is what keeps every other pattern trustworthy. A coding agent is only as good as the document it reads. So if the documents drift, the agent starts working against a stale picture. Two rules keep the build grounded. Start prompt based on the first repo, then harden the winning prompt into a skill once the output shape stabilizes, because a prompt does not survive scale. Then scope permissions. Analysis agents stay read-only, and anything that writes is limited to one repo. Whatever the agent gets wrong, it can only get wrong in one place. And gated in CI, so the discipline is enforced rather than advisory. Block any merge that changes a public surface until a fresh intent-driven analysis shows no unvalidated critical path edges. Now an example, with all four patterns composing on one real change. Engineering wants to add a currency field to the order record in order service, so orders can be placed in more than one currency. 3 services consume order data. 2 consumers read orders through a shared client library, a high confidence edge both documents agree on. The third ingests through a nightly batch job that appears only as a low confidence edge, so the analysis confirms it in the source. It sequences the work. The shared client library ships a version that tolerates the new field first, then order service adds and populates it. Then the 2 consumers start reading it. Then the batch job is updated. Across the migration, there is a compatibility window, the period where the old shape and the new shape both have to work, plus the integration points to test at each step and a rollback path. The reviewer flags the batch job as a one-way door, a change you cannot easily walk back because it rejects records with fields it does not recognize. So the document gains an explicit gate before order service starts writing. Then each coding agent reads its own repos document, plus the change scoped one, so it knows the conventions, the exact files, and the seams to write integration tests against. The failure modes here are predictable, so build against them directly. Require a human merge on everything. The agent will miss some runtime dependencies and invariants, so human review is the correctness gate. Nothing auto-merges, not documents, and not code. Make agents cite their sources. Every connector inherits the staleness of what it connects to, and a stale wiki page will mislead unless a human can see what the agent relied on. Handle data residency before CI rollout. Running agents over private source sends that source to a model endpoint, so use an enterprise or zero retention arrangement or a self-hosted endpoint. And tighten gates on critical surfaces. The engineers who most need this output are least equipped to catch subtle errors, so payment, auth, and cryptographic surfaces get stricter review, not lighter. The shift is from asking an agent to understand a system on demand, which fails the moment the system outgrows its context window, to maintaining that understanding as a durable, self-refreshing asset. The code is the only reliable spec, so ground the agent in the why, with skills for what changes slowly and connectors for what changes fast. The 4 patterns are independent, so you do not need to boil the ocean. Reverse engineer one repo and you already have something useful. And the documents that power the analysis are the same ones the coding agent reads to make the change. Start with a single repo and a single skill. Add dependency mapping when you have several. Reach for intent-driven analysis when a real change forces the question. Keep a human on every merge and let the understanding compound instead of decaying. Thanks for watching.